Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss phase velocity. Let's begin. The wave nature of matter can be proved by using de Broglie's hypothesis. According to de Broglie, that moving particle is associated with wave, and that wave nature of that of matter is known as de Broglie wave or matter wave. Since it is a wave, it possessed its wavelength, frequency and velocity. The velocity of that wave is known as the phase velocity. Now, the velocity of that of de Broglie waves associated with a particle can be derived. According to de Broglie hypothesis, a free particle behaves as a wave. Free particle in the sense the particle is not bounded, that is free. To define that wave, let us choose a plane wave. Let us choose a plane wave psi as a function of RT, R be the position and T be the time, and A e to the power I k dot r minus omega t. This is the basic mathematical representation of that of plane wave, where A be the amplitude, omega be the angular velocity, and k is the propagation vector of that given plane wave. Now, the phase velocity, therefore we define that of phase velocity. The phase velocity, let we prefer u vector of that wave is equal to the velocity with which a point of constant phase travels. A point of constant phase travels. That means we tell it as k dot r minus omega t is equal to constant, that indicates therefore k dot r minus omega t is constant, that is the phase of that given plane wave. Now differentiating that equation 2 with respect to time t. Now differentiating equation 2 with respect to t, we get that is k dot dr by dt minus omega is equal to 0, since r is the function of t and k as constant, or dr by dt is the u vector, k vector u vector is equal to omega to that side, that is omega, where u vector, that is dr by dt, is the phase velocity, of wave. Since the direction of that propagation vector, that is k vector, and phase velocity in that of same, we can write k dot u, that is ku cos 0 degree is equal to 1 is equal to omega, since the direction of propagation vector, that is k, the propagation vector and phase velocity is same. That's why the angle is 0 degree, cos 0 is equal to 1, or the phase velocity u is equal to omega by k, that is the magnitude of that phase velocity. Equation number 3, which represents the magnitude of phase velocity, that represent the magnitude of phase velocity, or we can say it as magnitude of that of wave velocity. Now this can be further written like this. We use this as u is equal to, let h cross omega divided by h cross k. H cross omega, that is for that of energy, and h cross k, that is for that of momentum p. Here where E is equal to h cross omega be the energy and P is equal to h cross k be the momentum. This one be the another way to represent that phase velocity in terms of energy and momentum. Equation number 4. Now we calculate the phase velocity for photon and that of material particle. Material particle in two cases, one is for relativistic case and another one is for that of non-relativistic case. You have to discuss one by one. First we calculate the phase velocity of photon. Phase velocity of photon. Phase velocity of photon. We know that E is equal to m naught square c fourth plus p square c square square root, that is energy in that of relativistic case where m naught is the rest mass. For that of photon, m naught is equal to 0. For photon, that rest mass is 0. Therefore, that equation changes to E is equal to p square c square square root, that is pc, or c is equal to E by p. In place of E by p, we can substitute u, that is c is equal to u. What that equation represent? The phase velocity of a photon, that is u. Therefore, that indicates the phase velocity of photon is equal to the velocity of light. The velocity of light in vacuum. This one is the important one. The phase velocity of photon, the phase velocity of photon is equal to that of velocity of light in vacuum. Again, we calculate the phase velocity for that of particle, material particle. Material particle in two cases, one for relativistic case and another one is non-relativistic case. Phase velocity of particle. Phase velocity of particle. First case, for non-relativistic medium. For non-relativistic motion, that is non-relativistic motion, what should be the phase velocity of that of particle? We know the kinetic energy of particle having mass m at non-relativistic velocity or that of speed of v. Can write the kinetic energy of that particle, let E is equal to half mv square. Particle having mass m moving with a velocity of v. We write it as like this, half multiplying 1m in that of numerator, then obviously 1m to that of denominator section, m square v square, that is mv is the momentum, that is p square divided by 2m. This one is the energy, that is p square by 2m, energy in terms of momentum. Therefore, the phase velocity which is u is equal to E by p, phase velocity in terms of energy and momentum. E, the value of E, that is p square by 2m, p square by 2m divided by p, or u is equal to, that is p by 2m, p, that is mass into velocity, the momentum, divided by 2m, 1m cancel out, that is v by 2, or u is equal to v by 2. That is the phase velocity of that of material particle in non-relativistic motion. From this expression we conclude What is the conclusion? The phase velocity of matter wave, the phase velocity of matter wave associated with a non-relativistic particle, associated with a non-relativistic particle is equal to, that is, half of the velocity of the particle, half of the velocity of the particle. That is, from that of mathematical expression, the phase velocity of matter wave associated with a non-relativistic particle is equal to the half of the velocity of that of particle. Now again, for that of relativistic motion, what happened? For that of relativistic motion, what should be the phase velocity of that of particle? For a particle of rest mass, let m naught, moving with a velocity which is comparable to that of velocity of light, we know that means E is equal to mc square. Here m is the mass of that of particle when it is in moves. In that of relativistic case, the expression of that of mass changes to m naught, that is the rest mass, divided by, that is the rest mass m naught, divided by 1 minus v square by c square, square root. That is P, this is the expression for E, then P mass into velocity, mass, that is m naught, divided by 1 minus v square by c square, square root, that is the expression for P. E and P is like this. Therefore we can write E by P, E by P, E by P will be c square by v, c square by v, or E by P is the u, c square by v, that can be written like this, c by v into c, c by v into c. We know that the velocity of material particle is always less than that of velocity of c. That is, we can conclude from this, that is, v is very less than c, since velocity of material particle, is always less than that of speed of light, c, or c by v is greater than equal to 1, or u is greater than c. That indicates, that expression indicates, we can write here u is greater than c. The phase velocity of matter wave, the phase velocity of matter wave is greater than the velocity of light in vacuum, greater than the velocity of light in vacuum, that is C. This is in the contradiction to the special theory of relativity. This is the contradiction to the special theory of relativity. Special theory of relativity. Thus, the velocity of the particle, both relativistic and that of non-relativistic, motion, is different. This one with the non-relativistic case, that one for that of relativistic case. These two are different. Thus, the velocity of the particle, both relativistic and non-relativistic motion, is different from the phase velocity of that of de Broglie wave associated with it. Thus, this puzzling diagram sometimes referred to as the velocity paradox of matter wave. From this, it conclude we can say it as the velocity paradox of that of matter wave. This is the significance of that equation. It can be written like this: velocity paradox of matter wave. Why it is velocity paradox of that of matter wave? Since the phase velocity in relativistic case and non-relativistic case are different from that of phase velocity of the de Broglie wave associated with it. This puzzling diagram is referred to as the velocity paradox of matter wave. Now, the phase velocity either depend upon either depend on the wavelength or not. Let us take a look. The dependence of phase velocity on wavelength. The dependence of phase velocity on wavelength. Either the phase velocity is dependent wavelength or not. The total energy of a particle of rest mass m0 and momentum p. We write like E, the total energy, the kinetic energy plus potential energy, that will be m0 square c fourth plus p square c square square root. Taking c square as common and to that of outside, it will be c p square plus m0 square c square square root. Okay. Here taking p also common, pc, in that of bracket term it will be 1 plus m0 square c square divided by p square. Here is the E. Our aim is to get U as E by P, phase velocity in terms of energy and momentum. Dividing P here, we get C 1 plus m0 square c square divided by p square square root. Since we know p is equal to s by lambda, therefore in place of p we substitute s by lambda. Therefore u will be c 1 plus m0 square c square lambda square divided by s square. Just we substitute s by lambda here. Look that of expression. for a free particle of a zero rest mass like photon, for a free particle, free particle in the sense like example like photon, the rest mass will be 0. Therefore, U is equal to C. Here this one is the independent of lambda. So, U, that is the phase velocity, is independent of the wavelength lambda. Therefore, we can write here for material particles for which m naught is not equal to 0. Here m naught is equal to 0. Again, for material particle for which m naught is not equal to 0. M naught is not equal to 0. That means the velocity, the phase velocity or the velocity of that wave is always greater than the velocity of light in vacuum. This factor will be there. Therefore, we can say that is always greater than the velocity of light in vacuum, and it will be depend upon lambda, and it depends on lambda. When m naught is equal to 0, it does not depend on lambda, but when m naught not equal to 0, then it depend on lambda, and it is greater than that of velocity of light. Thus, from this conclusion, from this consideration, we get the phase velocity of matter wave depends on wavelength even in vacuum. So, vacuum behaves as a dispersive medium for that of matter wave. Vacuum behaves as a dispersive medium for matter wave. Dispersive medium for that of matter wave. Why? Since the phase velocity of matter wave depends on wavelength in that of vacuum. So, with the help of this video lecture, we understand the concept of phase velocity, the relation between phase velocity in terms of energy and momentum. We treat it as the phase velocity of photon, then phase velocity of material particle for non-relativistic motion and relativistic motion, and finally the dependence of phase velocity on wavelength. We conclude these things. So, with this useful and informative notes, let me wind up this session. Thank you.